We're going to take a look at section 10-4, where we compare perimeters and areas when looking at similar figures. So you need to take a minute from chapter 7 and review what it means to be similar figures. In general, corresponding angles are all congruent, corresponding sides are proportional. So our first theorem here for this section, theorem 10-7, tells us that if we have a scale factor of two similar figures of A over B, then the ratio of their perimeters is A over B. So it's unchanged. So whatever that ratio is that compares the corresponding side lengths, it's going to be the same ratio that compares the perimeters. However, the ratio that compares the areas is going to be A squared over B squared. Or you could think of it as taking that whole ratio A over B and squaring it. Either way, A squared over B squared or A over B squared means the same thing. So let's go ahead and practice applying that to a few of our problems here. It says the trapezoids at the right are similar. The ratio of the lengths of the corresponding sides is 6 over 9, and we can see that here. The top length on each trapezoid is 6 on the top and 9 on the bottom. And it says, or 2/3. So if we take 6/9 and we reduce it, we get 2/3. So the first thing we want to know is we want to find the ratio of the smaller to the larger, meaning we're going to list the smaller trapezoid on top and the larger on bottom, of the perimeters. Now, again, if you remember back here what we talked about in this last theorem, the ratio of the perimeters is actually just the same as the ratio of the corresponding sides. So since we already know our corresponding side lengths have a ratio of 6/9 or 2/3, that's going to be the same result for the ratio of our perimeters. Just always verify that you are making sure you're listing them in the correct order here, smaller to larger. Part B is asking us for the ratio of smaller to larger of the areas. So again, if we review that theorem we were given, it says the ratio of the areas is equal to A squared over B squared, where A and B is the ratio of your corresponding sides. So in this case, we're going to have 2 squared over 3 squared, and that gives us 4 over 9. If you can reduce, always reduce. Never put an unsimplified answer in the homework boxes. But in this case, 4/9 doesn't reduce, so that's all we have to do there. Let's try another one. Two similar polygons have corresponding sides in the ratio of 5:7. Part A asks us to find the ratio of the larger to the smaller of their perimeters. Now notice, if we're given this as 5:7, that means that our first listing here, that 5 is going to be the smaller since that's less than 7. And I'm asked to write my ratio in terms of larger to smaller. So since I'm looking at perimeter, I'm going to have the same ratio as the corresponding sides, but I'm going to write the 7 on top and the 5 on bottom, since I am asked to list it as larger to smaller. And then part B asks us for the ratio, again, larger to smaller of their areas. And we said to find that, we just square the ratio of the corresponding sides. Again, that's 7 on top since it's the larger of the two. And that gives us 49/25. If you can reduce it, reduce it. If not, there's our final answer. All right, let's go ahead and put this into context a little bit further, where we can use these ratios to find areas. So our next problem tells us that the area of the smaller pentagon is about 27.5 square centimeters. What is the best approximation for the area for the larger regular pentagon? So since they're both regular, we do know that they're similar. All regular polygons of the same size, or the same amount of sides, are regular, or are similar. So since we know the ratio of the corresponding sides is 4:10, or 4/10, that tells us that the ratio of the areas is going to be 4 squared over 10 squared, or 16 over 25, which reduces to 4 over 25. So I know that the ratio for my areas is going to correspond to 4/25. So now I'm going to use that and what I know about the area of the smaller the smaller pentagon to find my missing area. So since the ratio for my areas is 4/25, I can set that equal to the area of my smaller pentagon, 27.5, over the area of my larger pentagon, which I don't know, so I'm going to leave that as x. And now, hopefully this looks familiar to you, something we can cross multiply to solve for x. So 4 times x is 4x, 25 times 27.5 is 687.5. Divide both sides by 4 to isolate that x. And x is equal to 171.875. So if we're looking for the best approximation, and we do have a multiple choice going on here, the area of the larger pentagon is about 172 square centimeters. So find the ratio of your areas by taking the ratio of your corresponding sides and squaring them, then set up a proportion and cross multiply to solve. Let's go ahead and try one more like that. The scale factor of two similar parallelograms is 3/4, or 3 to 4. The area of the larger parallelogram is 96 square inches. What is the area of the smaller parallelogram? So let's do the same thing we did in the last one to get started. Let's take the scale factor for their sides and find the scale factor for the areas. So to do that, take your 3/4 and square it, which gives us 9/16. So I know that they have a ratio of 9/16 from one area to the other. Notice the top number is going to refer to our smaller parallelogram and the bottom to our larger parallelogram. So this time when I set up my proportion, 9/16 equals, here I don't know the smaller parallelogram. So in this case, my x is going to go on top, and the area of my larger parallelogram is 96, and that's the value that goes on bottom. Cross multiply, 16 times x is 16x, 9 times 96 is 864. So again, divide both sides by 16 to get that x by itself, and x is equal to 54. And we're talking about the area here, so my units are inches squared. So find that ratio of our areas by squaring the ratio of the sides, and then set up your proportion cross multiply. All right, our last one here, we're going to work backwards a little bit. It says the triangles at the right are similar. What is the scale factor, and what is the ratio of their perimeters? So let's start by setting up the ratio of the areas and taking a look at that. And you could do this in either order. It doesn't tell us exactly how we want it, whether we want smaller to larger. I'm going to go ahead and put the smaller on top and the larger on bottom. So the ratio of our areas is 50 is the area of my small triangle, over 98 is the area of my large triangle. And I'm going to go ahead and reduce that, and I can divide both by 2, which gives me 25 over 49. So that's the ratio of my area. So that's like taking, if we look at this previous problem, and right here in this second step where we found the ratio of our areas by squaring the ratio of our sides. So if we want to find the ratio of our sides, we're going to need to work backwards. Since we squared to find the area, we're going to square root to find the ratio of the sides. So the ratio of my sides now is going to be the square root of 25 over the square root of 49, which is 5 over 7. So the ratio of my sides is 5/7. And the last thing it wants me to do is find the ratio of my perimeters. And if we remember from our first theorem there, the ratio of our perimeters is going to be equal to the ratio of the sides, 5 over 7. If you have any questions on this section, shoot me an email and I'd be happy to go over it with you.